Nearly everything we do is driven by code. Every line you write, or don't write, makes a difference. The choice is yours.
Welcome. Hello, everyone. Good afternoon. Really nice to see you all. This being a virtual conference, the first big virtual conference for me, thought I would be a bit less nervous, but I guess I'm only human here. Let me introduce myself first. Usually I'd really keep this quite short because I fully realized nobody came here to see me, but more for the content. But in this case, I think it will give you a nice context or where I'm coming from. I'm Sebastian, and I'm a hacker at the Rabobank Red Team. So we are ethical hackers. I'm also the tool manager there. And how I got there, well, studied computer science first. Then I joined the Rabobank as a front-end performance engineer. So you could think Rabobank.nl, but also Ideal and small part for the app at that time. And now we're talking 9, 10-ish years ago already. Working at Ideal, I really got interested in the world of payments. It eventually led me to join the SEPA payments team as a backend performance engineer. But as many other organizations, we started going into moving towards DevOps, and we were no different there. So I quickly became the performance guy, which also quickly led me to be the security guy in a way. And it really interested me. Doing all kinds of stuff, vulnerability management, range pen tests, all that kind of stuff. And then out of the blue, someday, crisis, we got owned by the Red Team. And that was really interesting to me. And dealing with that, I learned so much. So then when I noticed they had a job opening, I couldn't not apply for the job. And here we are, really. So I had a whole different kind of jobs before I joined the Red Team. But what is red teaming actually? So in corporate terms, we would describe it as increase the resilience for Rabobank with sophisticated attacks to address weaknesses against modern attacks. Which is basically saying that to increase our resilience, dus how well can we fend off attacks, the really sophisticated attacks, so not just the really simple stuff that beginners can do, but really advanced stuff, by actually applying those attacks and methodologies against our organization, in the hope that we're first, so we can fix everything before we become the victim of actual bad guys. So in a way, the good bad guys. Examples in, as you might expect, a lot of terminals, a lot of screens, a lot of things going on at the same time. Probably nothing you wouldn't expect here, but things we also do are without computers. So in this case, for example, on the left, you see a picture crawling into the ceiling there. What we did is walk into the building, really just pretending you belong there. Often really works. Confidence, knowing what you're doing, or at least coming across like you know what you're doing. Usually people will leave you alone. In the middle picture, we see the malicious hardware or the rogue device we placed in the ceiling there. We connected it to the network, which gave us access to that network. And through that network, we could reach things we should not be able to reach, and we can do things that we shouldn't be able to do. Just to be sure, if you put a big sticker on the door of a toilet saying it's out of order, don't use it, people tend to really not take that risk and leave everything alone. Works really well. And on the right, we see our lovely Santa and his helper. And this is also a case of act like you belong. We walked in, of course, during Christmas time, be very jolly, take really a lot of time and hand out gifts, be really nice. And we can get into places where we should not be. People don't tend to challenge that. That's also part of our work. And as you might imagine, it's not quite pen testing. Of course, we do the whole physical part of it, but also I think most of you, or maybe even everyone, has some experience with pen testing on your application, on your system. Maybe you do it yourself in a DevOps way of working. Really cool if you do that, by the way. But a lot of times I notice that people think pen testing is smaller and red teaming is bigger or more awesome. That's really not the case. It's just really a different approach. Where you get a pen test done on your system, what the pen testers will do is they have a clear defined scope. Your stack that you're running on, what parts are and what parts are not part of the scope, and your application. What they tend to do is knock and poke everything that's there to see if it's vulnerable, what's going on there, and can they abuse it? Is it vulnerable? So it's really a thorough examination of your application, but only your application. They don't zoom out usually and see the entire network and chain that is running there. So they really look at components. Red teaming, however, doesn't do that. What we tend to do is realistic attacks based on real threat actors. So we look around in the world, what is going on, what kind of attacks are happening and how do they do it, and which methodologies and techniques are used. And we try to keep up with that. Of course, it's a really fast-pacing world, so sometimes it can be really difficult. And we apply those techniques and methodologies onto our organization. And what we usually say is unannounced and hostile. We don't make an appointment for, hey, Monday at 4, can we hack your payment system? Or can we do it on a different time maybe? No, we just do it. And to emphasize here, we don't tend to want to break things. That's not the point. If we break things, we might be caught out because something breaks, investigation starts, maybe even a crisis team gets set up to look into what's going on. And the likelihood that we get found out there is way too big. So we're usually really careful. So hostile is not barging through everything. We tend to be really gentle. If we put this into a graph with all the steps and phases we go through, we come with something like this. Real hackers, and I mean, we are real hackers too, but I mean, the bad guy hackers, they tend to use exactly this methodology. And they might not put it in a graph and they might call it a bit different, but in a way, it ends up like this. All right, okay, maybe the bad guys don't do reporting. I'm not sure. I guess they don't. As long as they get the money, they're probably happy. And on the bottom left, you can see initial compromise. That means the first time we get access to a system or a network, or maybe the entire organization. And that could be a really sophisticated hack on a server somewhere, but it could also be a phishing mail, for example. And I'm sure loads of you get the training phish emails. And they can be quite silly sometimes, or you can find out really easily, oh, this is fake, right? This can't be real. Report, done, get a check mark behind your name. But if they really do their homework and they really tailor it to you and your surroundings in the organization, make it look real, maybe add that you have a baby and you had a bad sleep during the weekend on the Monday morning. Eventually, people will fall for phishing mails. And that can lead to a compromise of a system. But regardless, initial compromise can be really difficult. To get foothold into a network or an organization can be really difficult. But once we're there, it's not finished yet. As you can see, we have this big loop going. And that's what happens after we get into the network. What we do is we start with internal recon. So we tend to be really gentle and careful to just look around, leave no trace, don't trigger any defenses or whatever might be there. We don't want to spook people into reporting, hey, my computer is acting weird, or why is my server suddenly doing different things than I expected to do. We want to be unnoticed. We just start looking around and going through. Once we made a plan of the next step, we can take it, and then we take the loop again from that new spot. We keep doing that until we reach our goal. And a goal might be to ransomware all your servers and remove the backups. Or it could be, if you're in a financial organization like Rabobank, steal as much money as we can. Or anything else you could think of. Some people only do it for the lol and break things. It's hard to say what the goal might be. For us, we make up a story and design our goal up front and work towards it. So in the end, we end up with a chain. Some people call it a kill chain, for example, where you have your initial compromise and then all these little hubs towards your goal. And that's really not like you see in most movies. In the movies, you have, of course, the really nice, super fancy graphics and effects and animations and all that. We don't have anyone doing design in our team, so everything looks just like a terminal. It's just white text on a black background, usually, and that's it. But the other big difference is in the movies, they usually attack the target directly, regardless of where they're coming from. So if you imagine, for example, if you've seen the series Casa de Papel, they're going in and they could hack the front door gates directly by just starting their hacking machine and tip, 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 and they could open and close the gate directly. But in reality, it's almost never like that. You have only a small portion facing the internet and the outside. Everything else is on your internal network, which you cannot just walk in and access directly, right? So that's really a big difference. We really need to get into the network first, regardless of how we do it. It's usually never the actual goal system. So we need all those hubs. If you want to really make it difficult for us, you either remove possible hubs when we're working on it, but if you also remove, before we get through it, those hubs, it makes our path much more difficult. And that's something I really sort of knew already, of course, but once I joined the red team, it really became obvious and clicked. And I really had this moment in, why did nobody ever really explain this in this context to me? When I still was in the DevOps team, we all get those Scud missiles or rockets to your backlog. You try to keep your order there, and then out of the blue, some security thing comes up, of course, with the highest priority. And there goes your planning, right? And of course, it's important, but they don't really tend to give that much context or why is it important. So this is a bit what I'm trying to explain and give you that context. So if we shortly summarize the red team or the getting hacked, it's always you get your initial foothold. So someone gets into your network. Then we call it lateral movement. That's the hubs I talked about. And it can be 2 hubs. It might be even 20. it is really important to understand that getting hacked is not something that happens fast. Like one of those steps can happen fast, but usually the entire chain in a complex compromise can take months. So if you look at quite recently, we had the University of Maastricht. They got completely ransomware, backups destroyed, and they really ended up having to pay to get it recovered. Worst case scenario, right? Once they started looking into it, they found out the hackers were in their network for 2-3 months. And they used that same chain. It's always the same. Someone gets in at some point, and they were able to find a route through the organization and through the network to get to the entire goal. In this case, ransomwaring the entire system. And we're lazy. We go for the easiest route. So if we can find 5 possible next hubs, we take the one that is most reliable and the easiest for us to do. Because why wouldn't we? But this also means that once you got red teamed, we managed to compromise your system in some way. Of course, we make a report, we help you understand what's going on, we help you fix that. But once it's fixed, that does not mean that you are completely 100% safe. 100% safe is already a bit weird. It's almost not really possible, but it means you're safe from the exact scenario that we played out. There might be other paths that we didn't take. And there might be for the next time we get red teamed. If we can, we still mention it in the report. We didn't do this, but it's still possible. You should look into it. And sorry, that's out of scope. Said no hacker ever. And that's really also an important part in organization. It's quite often, okay, this is the important things, and this one, yeah, it's less important, so it gets less attention. It's probably out of scope for whatever it might be. For example, for your pen test, you usually pen test your core application and that you're running, but the other things usually don't. So your application itself might be very secure. You have a really solid stack, you do everything correctly, and your app is super secure because that's why your team exists. To run that system and keep it up and do it in the best way that you can. But what about everything surrounding it? Sometimes they get a bit neglected. Your backlog is already really full. Everything's pushing for a priority, and the rest around it, it's kind of working. So maybe next sprint, maybe next quarter, we'll see, right? I'm sure this rings a bell for a lot of folks here. Yeah, there you go. So what's the things that we come across quite often that make life too easy for us as a red team? Incorrect way of working with secrets, for example. Keys in Git or anything else that should not be in Git. Credentials in public internal wikis or Confluence maybe, or whatever you might be using. And then it's really important to have open knowledge and sharing of knowledge and experiences. So I'm not saying close everything down, because that's really not what we need as an organization. What we need is storing keys and credentials in the proper locations where they're safe. So if I'm in your network, we're going to have a field day trying to find all the public documentation and read all about what's going on. And that might give us information about your stack and how to onboard a colleague and all that kind of stuff. But that's not all that useful for us. But if you also store, if you want to get on the test Wi-Fi for mobile devices, use these credentials and this SSID for the Wi-Fi. Okay, that's going to go into our notes. But yeah, keys in Git also, don't store them there. Store them in whatever system you have in place in your organization to do it properly. And we talked about pen tests before. They will make a really nice report with everything that is wrong and open. And if it's not fixed yet, that's going to save me a lot of work. Just read it, check the date, interesting, and go from there. So that's a good one. And I know it sounds really trivial, but keeping in mind that we want to plot our way to our goal, even credentials for a system that might not be important for you, because it's not your main reason of why your team exists, is still very valuable for me, because that can mean I get access to a different Linux server. And on that Linux server, we might be able to become a higher privileged user and go from there. So even those little things for maybe even a test environment are valuable to us as hackers. Then we get to the odd software, and it says legacy there in the bottom. It doesn't have to be legacy per se, but it's usually what it is. It's used once upon a time, and we don't want to get rid of it because ... just in case. Imagine you had the old school stack with Jenkins and everything going on, but you move to the cloud now, you use different things. But in your old CI/CD pipeline, there might be some things that we want to use later again, or just to check how it was done previously. So your PO doesn't want to get rid of it. But also there's no real time to keep that whole thing up to date and up to spec and to the modern standards. And then it becomes a problem, right? It's annoying because it becomes old and nobody really wants to work with it, becomes a drag, but it also becomes a real big risk to get compromised. And also here, it might become compromised and it might not impact your application in production, but it could be one of those steps towards the goal to get ransomware. And then we also see the software that is not common in an organization. By being the odd one out. Sometimes there's really no other chance to go and use that really specific software for your use case. Then that's fine, of course. But then you also have to understand that you really need to run it, keep it up to date, and give it all the love and attention that it needs to keep safe, secure, stable. It's really important. But preferably, you use whatever is common in your organization, so you can get support, you can get help, and you're never the only one that needs to figure out what's going wrong and how can I fix this, because there's tons of other people using the same. And then we get to one account to rule them all, which means, users or maybe service account, non-personal accounts, functional accounts, however you want to call them, or whatever kind it are, is big risk. Because if we get access eventually to that account, in whichever way, that will open so many doors for us. And every door we can open on a very normal, proper way means it is really hard to detect us and fix it. Because a service account is not even usually human involved directly. So if we start using it, we can open all those doors to different systems and applications and environments maybe, that no one will notice that we're doing it, because it's only a normal login and it's working as intended, right? Imagine if you get phished and we're on your laptop, and from your laptop we start using one of those accounts. For the monitoring folk, it's gonna look like that account is used in a normal way from that laptop, doing normal things. So try to keep it down on the amount of especially service accounts and what they can access. Really keep it to the minimum that is necessary for your work. And then we get to not the last one before the last one. Is not enough divide between development, tests, and prod. For example, using the same users, the passwords and key, keys. And I know in DevOps way of working, we tend to, everyone is the same and everything is the same to a certain level. But then it's still advisable to have some difference for prod. For example, you have a Linux user and you can log in and change things in development and in test, because that's your work. You need to do your things there. But it would be a really good idea to have a for-I principle or a script where you have to request temporary privileges for maybe an hour, and someone has to approve it to make changes in production. So that when we get in those in those hubs, we can get into your dev and we can get into your test, but maybe it will prevent us from getting into production, which is, for example of ransomware. If we ransomware your development or test, it's really annoying, but it's not the end of the world. But if we manage to get into prod and then do the bad things, that could be a lot more painful. And as the last one, dangerous misconfigurations that can be oh so convenient. For example, broad access through sudo. If we go back to the example with a Linux account, and you can access that server, but your account doesn't have that much access, which is in a way is really good. But if you set up sudo, you can do things as if you're root. And if you misconfigure that or make the access too broad, that means then once we get access to your account, we can do things as root. And our more experienced hackers, they can go from your account using sudo, especially if there's wildcards or whatever in your sudo rules, that can be very, very vulnerable, where we can eventually lead to becoming the root user, and then the entire server is ours. We can do what we want. So really take a good look at that kind of rules and configuration there, and look at them with a critical eye. That leads me to my advice. Most important thing, in my opinion, is try to apply thinking as a hacker to all aspects of your work. If you're already doing that for your core application, really good, awesome. But try to do it on the rest of whatever you're running and using also. How can I abuse this? It's good for security. It's also good for stability and performance. In how can I abuse this? How can I make this break? It's meant to work A, B, C, but can I break it by going B, A, C, for example? And think out of the box, outside of your usual way of working and thinking. And then also challenge that we always did it this way. Maybe you just join the team and they tell you, this is how we do it. But maybe you've already been in that team for 8 years, and something that started off small became quite big. It ballooned into something that is no longer the way it should be doing. For example, if you start with a small Confluence page and you put some details there about, oh yeah, these are the servers for prod and this is for test. The next guy comes and, oh yeah, login for these systems work this way, and here you have to log in that way. And then even more later, you have many more environments and more people in your team. It becomes really easy. Oh yeah, database access, username, password. For test is username, password. And slowly it becomes something that should not exist anymore. So challenge that. Challenge that we always did it this way. And I know this sounds trivial and you might have heard it before, but I hope with the context I've given you that all those little steps really make a difference. With that context, that you understand that it can actually be really important. And with the involving and convincing your management or PO to leave nothing behind. For example, I used the Jenkins, but now you're using stuff in the cloud. Make sure that as soon as you start working on that as a team, that part of it is also, what are we going to do with the old stuff? Will we get time and to keep everything running? And then it's I advise you to say, okay, but this is going to be a lot of time for almost nothing. Best thing, just get rid of it. Make sure that you store whatever information that you really need in a proper way, and then get rid of it. Because what's not there, it cannot get hacked. And it's never going to be a drag if it's not there. It's really the easiest way. And then finally is hack yourself first. In my opinion, it really helps in thinking as a hacker and trying to think out of the box, out of the usual, it's supposed to be used this way, is to start hacking. And that can sometimes feel as a really big thing to start on. But keep in mind, it's a journey and we all start somewhere, and that's okay. Some might have trouble with what I call really easy. Some of you might be so good at web stuff that medium to hard hacks on that regard are very doable for you. Maybe you didn't even realize. So I've got a few things where you can start with. We all know the OWASP top 10, I think. You've got Juice Shop. And they got a bit more than just the OWASP top 10, but it's a really good starting point. I recommend this all the time. It's awesome. It has 100+ challenges. There's write-ups that explain how to do it if you want to learn from it. And it uses a modern stack, Angular, Node, etc. Thing is, you have to host it yourself, either in a VM or locally. Then we get to Porttrigger, which is, Porttrigger is a company, but they always use strange names for their tools and software. We have to live with that. And they have an academy where you can learn a lot from them. They have loads of learning materials and they explain it really well. And then they also have labs, also free, where you can apply those techniques directly. So, and it goes from really easy to extremely hard, but it's all web-based. Now, if you're more into Linux or you're more of the Windows kind of guy, there's Hack the Box, which is vulnerable machines and servers hosted by them in virtual machines. So you can, and it's actually over the network, and you can really hack them. And they range from really quite easy to really, really hard. We as a red team often go to Hack the Box to challenge ourselves, to work together on a problem, figure it out. So there's something there for everyone. They've quite recently also added some challenges with web and that kind of stuff, but the most well known for their virtual machines. Then we have Try Hack Me as a last one, which is a nice mix of everything: challenges, learning materials, and machines to hack. And if you put some time into one of those four, maybe have a look at all of them, you might find it enjoyable and you might learn a lot from it. But these four are the recommendations I always make. It's a really good starting point. And then we came to the questions. We have about, I think 10 minutes for questions left. So if there's too many and your question doesn't come through, I'm very approachable. So hit me up on LinkedIn there or on Twitter as Reset Flag, and I'll help you out. Thanks, man, and see you around.
Code is everywhere. You get up with it in the morning. You take it with you on the go. It brings us closer to one another. It makes life easier, nicer, and it allows you to discover the world, make new connections, realize ambitions. It may even save your life. Nearly everything we do is driven by code. Every line you write, or don't write, makes a difference. That's why we write code that contributes to a better world, that helps shape a sustainable food chain, that empowers people to become financially self-sufficient, and gives people back control of their data. Whatever you dedicate your talent to, or don't, makes a difference. The choice is yours. What difference will you make?